In this video, we're going to look at how you can be able to solve trigonometry questions. And we're going to start by looking at the first question here. We're told by first expanding cos theta plus sine theta squared, find the three solutions of the equation cos theta plus sine squared theta equals to 1. You are supposed to find the values of theta such that theta is greater than or equal to 0, less than or equal to pi. Now, in order to expand this, first we're going to write this as follows, and then we're going to express this as cos theta plus sine theta, close the bracket, then we write this one. So you're going to multiply cos theta by the two terms in the second bracket, and also sine theta multiplied by the two terms in the second bracket. So if we open this, we're going to get, this is cos squared theta, and this becomes cos theta sine theta. This becomes sine theta cos theta, which you can also write as cos theta sine theta, plus sine squared theta. We're going to put the like terms together, and this is going to simplify to cos squared theta plus sine theta squared theta sine squared theta plus 2 cos theta sine theta. But remember, sine squared theta plus cos squared theta, that is equal to 1. So we're going to end up having this expression as 1 plus 2 cos theta sine theta equals to 1. By taking 1 on the other side of the equal sign, we're going to remain with 2 cos theta sine theta equals to 0. Then we can be able to say divide by 2 both sides. This will cancel out, and we're going to remain with cos theta sine theta equals to 0. And at this particular point, we can be able to say sine theta equals to 0 or cos theta equals to 0. So we're going to solve for the two, and sine theta equals to 0, we can be able to find theta by finding the sine inverse of 0. Sine inverse of 0, that's going to be 0 or 180 degrees. So we have two solutions, 0 or 180 degrees, and remember 180 is the same as pi. We need also to go back to cos theta equals to 0. Then if we find cos inverse of 0, we are going to get our answer as a half pi. Three solutions, we have three solutions: theta equals to 0, half pi, and pi. These are the two solutions. These are the three solutions that we are expected to get in this question. If you are new to Proflan YouTube channel, consider subscribing so that anytime we are going to upload future tutorials, you'll be notified. Now we need to go to the next section of this so that we can be able to see also what we are expected to know. So here we are told that let us proceed to the next question. And which in Roman 2, we are told, hence verify that only solution for equation cos theta plus sine theta equals to 1 for theta greater than or equal to 0, less than or equal to pi are 0 and a half pi. So in order to verify this, what we're going to do, we have obtained different solutions for theta, three solutions in the previous question. So we're going to substitute them into this equation so that whether and check and see whether they satisfy the solution. So we're going to substitute theta equals to 0, theta equals to pi, and theta equals to a half pi, and get to see whether it satisfies. So if we substitute into this, let's see what we're going to get. The first part, this equals to 1. So we're going to say theta equals to 0. So we're going to substitute, and we're going to see cos 0 is 1, and sine 0 is actually 0. So this is going to end up giving us actually 1, because this 1 plus 0, which is 1, and this satisfy. Then we're going to substitute also in the case where we have cos half pi, and see whether it satisfies, and also we can see If we do that, we're going to get that is 0 plus 1, and that actually satisfies. So let us check when theta equals to pi and see what we're going to get. In this case, is not equal to 0. So if you substitute, you're going to get -1, which is not equal to 0. So the only solutions we have here is 0.5 pi. In part B, we are told to prove the identity sine theta over cos theta plus sine theta plus 1 minus cos theta all over cos theta minus sine theta equals to cos theta plus sine theta minus 1 over 1 minus 2 sine squared theta. So in this case, we are going to use the left hand side to show the right hand side. So we're going to start by writing the way the expression is. So we are using the left hand side to show the right hand side. Now in this case here, we're going to multiply all through by the LCM on the left hand side. So we are having this case here. So cos theta plus sine theta, and the second term denominator is cos theta minus sine theta. So the LCM in this case is going to be the product of the two parts of the denominator, and we're going to multiply all through by the denominator and express as a single fraction. So having this, multiply this side by the LCM, this part which is the LCM, multiply it here, and also we multiply the LCM on this other side here. So you can see this particular part and this will cancel out, and also cos theta minus sine theta will cancel also on the second term. Now expressing as a common denominator or a common fraction, that is, which is the LCM in this case. In this part top here, we're going to remain with sine theta into cos theta minus sine theta. And in the second term here, we're going to remain with plus 1 minus cos theta times the second part of the fraction that remains. So whatever we're going to do in this case, we're going to open the bracket in the numerator so that we can be able to simplify and put the like terms together. So as pretty as that, let me just move this so that I can be able to get enough space so that we can be able to work out this. If we open the bracket, we're going to end up having this type of expression. We have sine theta times cos theta is going to give us sine theta cos theta. Sine theta times sine theta is going to give us minus sine squared theta. Then we're going to multiply also this term to this term, and also 1 to the second term, and this is going to end up to be cos theta plus sine theta minus cos squared theta. All right, moving on, we are going to put the like terms together and cancel out anything that is not really adding up, so that we express as a common denominator. Of course, if you expand the denominator, you're going to get cos squared theta minus sine squared. Okay, this is going to become cos theta plus sine theta minus sine squared theta minus cos squared theta over cos squared theta minus sine squared theta. Then we're going to rearrange this so that we can be able to say this is the same as cos theta plus sine theta minus into bracket sine squared theta plus cos squared theta, so that this term that is in the bracket is going to reduce to 1. Yeah, because we know sine squared theta plus cos squared theta is usually equal to 1. So we can now say cos theta plus sine theta minus 1 over, but now because on the right hand side of this expression that we were to show, we are having the denominator, we're having sine squared theta. So we're going to change that cos squared theta to sine squared theta, and this is going to be 1 minus sine squared theta minus sine squared theta. So can see we are having negative sine squared theta, negative sine squared theta. That's going to reduce to negative 2 sine squared theta. So finally, we have our expression as shown in part B. So basically, that's what you are supposed to do in this question. We need to move straight to another part of this question. All right, so let's see. We have part C, whereby we are told that using the result in A Roman 2 and B, solve the equation. Solve the equation. So you are using the result of A Roman 2 and B to solve this. Remember, the whatever we have in the left hand side here, we have simplified that, and we know it can be replaced with cos theta plus sine theta minus 1 over 1 minus 2 sine squared theta. So we can be able to replace that part with whatever we have and whatever we got in the previous question. So you can see that part that we have there can be replaced. Yeah, so let's move in so that we can be able to write that properly. That part can be replaced with this, and we're having equals to 2 cos theta plus sine theta minus 1 like that. Then we can see that this part those two terms will cancel out, because if you divide both sides by cos theta plus sine theta minus 1, the two are going to cancel out, so that we can be able to simplify this further. We have this as 2, so we can be able to multiply by we can simplify this, yes, and this can simplify to what? This can become, and then we can maybe multiply by 2 both sides so that we can be able to remove the fraction, and then we simplify it to the fullest. And finally, we're going to have this as a sine squared theta over 1 over 4. Then we can be able to find the square root both sides, and then we are going to have sine theta equals to plus or minus a half, which we can be able to say now to solve for sine theta equals to positive a half. And this means, you see, when you are solving these kind of questions, you check on the other side of the equal sign, is the answer positive or negative? We are told sine theta equals to positive a half. So this means we're going to find the values of theta in the quadrant where sine is positive. That information is very important. So this means we need to find the values of theta where sine is positive in the quadrant. So we have all students trust Cambridge. Then we know that sine is positive in the first and in the second quadrant. In this particular quadrant and this quadrant, that's where our angle is going to lie. So we are going to say this is going to be theta is sine inverse of 0, or rather a half. Sine inverse of a half, this is going to be what? If we find the sine inverse of a half, can you try to use your calculator and see what we're getting? And also the angles here must be given in radians. So let's try to work it out and see. We're going to get our answer as 1 over 6 pi. So the first solution is 1 over 6 pi. The next bit we're going to yes, this part also is 1 over 6 pi, but now you are measuring the angle from the x-axis 0 degrees all the way to where that straight line in the second quadrant is. So basically that's going to be pi minus 1 over 6 pi, and that's going to translate to 5 over 6 pi. All right, when sine theta equals to negative a half, so the angle theta is going to be obtained in the quadrant where we have sign negative. So in which quadrant is this that we're talking about? This will be in the third quadrant and in the fourth quadrant. In the third quadrant and in the fourth quadrant. So if we find this is in these two quadrants, that's where we are going to find our angle. Sine half of theta, we are going to work out the sine inverse of negative, that is going to be negative 1 over 6 pi. So that means negative 1 over 6 pi means that angle is going to be measured in the clockwise direction. So that angle is going to be here below the x-axis. Yeah, so that angle is going to be there. So we shall place it here. So that is where the angle is. So in order to find the angle that satisfies sine theta equals to negative a half, we're going to measure the angle in the clockwise direction. Because we are finding positive angles, we're going to measure it in that way. So in order to obtain that, that will be actually 2 pi minus 1 over 6. And if you look at this, you are going to get that this is going to be 11 over 6 pi. And ideally, this is actually out of the range. If you look at the range that we are given, this is out of the range, so we are not going to take this particular angle in this case. Now, we have two angles, values of theta here. We have 1 over 6, and also we have 5 over 6 pi, 1 over 6 pi and 5 over 6 pi. Then remember also there is another angle that we had obtained from the previous section, because that's going to be now 0. So we are going to have three solutions. The two solutions that we had gotten from the previous section are going to be part of this solution, because you can see you were told using the results in A Roman 2 and B, find your answer. So we have two angles that we have obtained at this current stage, which is 1 over 6 pi and 5 over 6 pi. There are other two angles that we had obtained in the previous section, which is 0 and a half pi. So this becomes the four solutions for this particular question. Moving to the next part here. Show that the equation 3 tan squared x minus 3 sine squared x minus 4 equals to 0 may be expressed in the form a cos x power, that is a cos raised to power 4 x plus b cos squared x plus c equals to 0, where a, b, and c are constants to be found. Now, in order to show this, we're going to remember that actually tan equals to sine over cos. So we are going to express this 3 into sine x over cos x squared minus 3 sine squared x minus 4 equals to 0. Then we're going to simplify these two, this, whereby we shall have 4 equals to 0. Then we shall multiply all through by cos squared x, so that we can get rid of the denominator. We multiply all through every term by cos squared x, so that we can be able to get rid of the fraction. And this is going to simplify to 3 sine squared x minus 3 sine squared x minus 3 sine squared x cos squared x minus 4 cos squared x equals to 0. Then, since we are having terms mixed here and we are supposed to give our expression in terms of cos, we're going to substitute. Anywhere we have sine, we're going to replace that with 1 minus cos squared x, so that we can be able to simplify this equation further, because we know that sine squared x equals to 1 minus cos squared x. So this expression is very important, which we are going to substitute into the previous section that we had obtained, so that we can be able to get it in the correct form that was expected. So we need to put the like terms together and simplify further, and this is going to translate to this, which becomes 3 cos power 4x minus 10 cos squared x plus 3 equals to 0. But remember, in this question, you are told that a, b, and c are constants to be found. So don't forget to write the exact values of those constants that you are told to find. We need to move to the next part, and if you are getting value from Proflan YouTube channel, consider subscribing so that in time we are going to upload further tutorials on topics that seem to be a bit difficult to students. You'll be notified. And if you're going to sit for your exams, I really wish you the best, and I wish you the best of luck. Don't forget to share this video to any of your friends, and also remember to subscribe, and also leave a comment down below if the video was helpful. We need to move to the next part of the question here, and we are told this. Very interesting. Solve the equation this for the values of x greater than or equal to 0, less than or equal to 180 degrees. Now let us go straight ahead. We've been working out question to do with radians. Now we're going to see how to use degrees here. So I'm going to use this expression. There's an expression that we have worked out in the previous section. That's the expression we are going to replace with 3 tan squared x minus 3 sin squared x minus 4 equals to 0, because that's the main reason as to why we were able to simplify that particular part so that we can be able to use it here. So we're going to write the previous expression the way we had gotten it, and let's see what we can be able to get. This is equal plus 3 equals to 0, so which means that we can let cos squared x equals to m, so that we can be able to form a quadratic formula. And we're going to solve this quadratic formula so that we can get the value of m. Once we have the value of m, we can be able to go back to the cos squared with the value of m that we have obtained. And in this case, our values of m are m equals to 3 or m equals to 1 over 3. So we're going to now go back to the previous section. It's quite interesting. We are getting m equals to 3. Now, in this section where m equals to 3, in fact, you are going to, let us just do it. You are going to see it's a useless answer because it's going to take us nowhere. See, if we find a square root, we are going to have cos squared x equals to root 3. So if you try to find the value of x, you'll realize that this is going to become the cos inverse of root 3. And actually, there's no way you can be able to get the cos inverse of root 3. Root 3 is a very huge number for cosine. And in that case, if you try to put this information in your calculator, if you don't trust me, you'll find that the calculator is going to abuse you because you're trying to put in some information that is not valid. So this answer that we got as m equals to 3 is very useless. We need to make use of the useful and the beautiful 1 over 3. So we're going to say cos x equals to 1 over 3. This is the most important part. When we find the square root, we end up having plus or minus 1 over root 3. So we are going to have two equations which we are going to use in order to work out this part. So in this case, we have positive. So we are going to see where cosine is positive. In which quadrant is cosine positive? All students trust Cambridge. Then we can now check in which quadrant is cosine positive. Cosine is positive in the first quadrant and also in the second quadrant. So in these two sections, that's where our angle is going to lie. So the first part of the angle, the second angle will be the angle running all the way in the anti-clockwise direction up to this point. Yes, we are finding positive angles, so you measure angles in anti-clockwise direction, so that let us just put in cos inverse of 1 over root 3. This is going to be 54.7 degrees. So this particular angle that we have at this point is 54.7 degrees. Also, this angle down here is actually 54.7 degrees. But which angle are we finding? The angle behind. So this is going to be 360 degrees minus 54.7 degrees, which translates to 330, 305.3 degrees. But we need to check the range. Is the range up to 360? No. The range was x from 0 all the way to 180. Now, in that case, this answer that we have obtained is going to be out of the range. Let's look at this. This is the maximum angle is 180. So this angle here is outside, out of the range. Yes, I have done it intentionally so that you could see if the range was given up to 360, that part of the answer was supposed to be part of the solution. But in this case, because of the range, this is not going to be part of the solution. Now we need to go further and analyze the second part, because x equals to -1/3. And now I told you, when you have negative there, that is telling you which quadrant is your answer going to be. So we are going to say this is going to cause negative is in the quadrant. Which quadrant? Let's see. All students trust Cambridge. Then we want to see where cosine is negative. This is going to be in the second quadrant and in the third quadrant. So the first thing to do, we can find this angle, cos inverse of -1/3. At this particular point, we can let us try to see it. This angle is going to be where? It's going to be 1.25, rather 125.3 degrees. So this is going to be at this particular second quadrant, and you can see now that is the angle that we were talking about. And if you can look at it, it's within the range. So this is beautiful. We are going to be happy with that. And this is one of the solution. We have two solutions. The answers for this particular question is 54.7 degrees and 125.3 degrees. Those are now the solution for this particular problem. If you have gotten value from this tutorial, consider subscribing so that anytime we're going to upload further tutorials, you'll be notified. See you next time.